Hi everybody.
Hello.
Hi Weronika.
Hi.
Welcome to the third recording. Let's get started. Okay. Dropping an object. Starts from 0 speed. After 4 seconds, what's the speed?
40 meters per second.
40 meters per second. The average speed?
20.
20. And we take the average speed, which is 20 meters per second, and we multiply that by the time, which is 4 seconds. So that gives us the distance, which is 20 times 4.
20 times 4, it's
80.
80 meters.
Good, 80 meters. So when we throw something horizontally, and we throw it horizontally, and it's 5 meters over the ground, then the vertical speed is 0, and we are 5 meters over the ground. Do you remember? Can you remember how many seconds does it take to get to the ground?
So we are
5 meters
and
over.
it's 10 meters per second. So
The average is 5.
The average is 5 meters per second.
The average.
So it's 1 second.
1 second. Bravo. So when I tell you how long, you can tell me what's the final speed, what's the average speed, what's the distance. I can also tell you the distance of 5 meters, and you give me the time, the final speed. So good. I can also play this game. I can give you the final speed. Let's say I dropped something. I don't tell you the height, but I tell you the final speed when it hits the ground is 20 meters per second. How long did it fall for?
20 meters. Final speed was 20 meters. The average speed is 5.
And so
So how do we do it? Do I just which do I choose? Do I choose 10 meters per second?
yes, that's the average speed, right?
That's the average speed. Okay.
Okay. So.
And the final. So it was 5. You were asking about time.
Yeah, we can start. Let's start with time. Good. You are enthusiastic. This is very good. I'm enthusiastic too. So let's start with time. We dropped something. I tell you the initial speed is 0. The final speed is 20. So how much time did passed?
2 seconds.
2 seconds. And the average speed?
10.
And the distance, therefore, 10 times
10 times 2 seconds.
is
20.
20 meters. Good. So 3 things: time, distance, and speeds. And I give you either one, you can tell me the other 2, because they are all connected with this constant acceleration. Wonderful. Now we combine the horizontal speed with the vertical speed, like we did with the train. So we drop something. It's 5 meters over the ground. So we said, how many seconds to reach the ground?
5 meters over the ground.
So
it's half of the second?
yeah. Well.
No, it's like 10 meters per
That's the
second.
final speed.
That's the final speed, and it's like 5 meters, so it should be half of the
Yes.
half of the second.
Yes. The 5 meters. Yes, you are right. If I drop something and it hits the ground at 5 meters per second, then the traveling time was half a second, right? Now I want to drop something for 1 second. Okay, so it hits the ground. What's the speed?
10 meters.
And the average speed?
5.
And the distance? 5 times 1. 5 meters. Good, good, good. I just want to do this little trick, okay? I drop something at this situation, 1 second, only 5 meters drop, yeah? But I also give it 1,000, meters per second velocity horizontally. I can do it. It's a bullet. That's a bullet, right? And so I throw this very fast ball, and it will hit the ground in 1 second, right? Because the horizontal and vertical speeds are not connected. So just one question for you: how much did it travel horizontally?
So it's 5,000 per second, and it will hit the ground after 1 second.
Yeah.
So it will travel 5,000 meters.
I said 1,000, but 5,000 is just as good. Yeah, I could have said 5,000. It doesn't matter. Yeah? I could have said 1 million. It doesn't matter. Excellent, excellent. So this is all this subject, and to you people watching, we are just. I think this is as far as we'll go today with horizontally throwing things under the influence of Earth's gravity, and working with this constant acceleration with speed, distance, time, and seeing. I can say something like, let's give you another one, okay?
Okay.
I throw something up from the ground at 10 meters per second. How long until it touches the ground again?
2 seconds.
2 seconds. Wonderful. You're an expert already. And simultaneously, it's on a train, right? And right. We did this one already, but we can play with it, yeah. Now the train is moving at this is what we did before. The train was moving, let's say, at 10 meters per second, and the time it took for the ball to go up and down is 2 seconds. So how long did it travel?
I don't remember the speed of the train.
The answer is the speed of the train times 2.
Okay.
Yeah? Doesn't matter. But it's good that you don't remember, because it's really not important. Very good that you don't remember. So you can see how it's possible to play with these things. I can throw something at any angle, and you say, okay, this is actually the speed in this way, the speed in this way, and you can know everything, really. Okay, final thing for the day. How do you feel? Full of
data.
Full of data. Okay. This is going to be really easy. The force that the Earth is pulling us is because of its mass. And the reason why everything falls more or less at the same speed, the same accelerations, is because we are all tiny compared to the Earth. Yeah? But actually, if you would take Mount Everest, and drop it from a few kilometers in the air, it would actually fall slightly faster than if you would drop yourself. The force would be greater, a little bit, because Mount Everest is still quite tiny compared to the Earth. Take the moon, yeah? You take the moon, and that would fall very fast. If we were to be, Earth and moon won't be rolling around each other. Anyway, so I just want to say, if you multiply the mass of the Earth times 2, the acceleration will be times 2. So if you drop something, after 1 second it will not be 10, it will be 20. Very good. And if you make it half of the mass of the Earth, then after 1 second it will be 5. Okay. Now, if you make the radius bigger by a factor of 2.
Radius of what?
Of the Earth. So you make the distance between us and the center of the Earth bigger times 2, then the force will be smaller times 4. And if you make it bigger times 3, the 4 means 2 squared, yeah? So if you make it bigger by 3, the force will be the distance between us and the center.
Then it will be 9.
9 times smaller.
9 times smaller.
And if it's it's going to be half the distance, the Earth will be contracted, so the force will be bigger. And if it's contracted times 2, so the force will be bigger times 2 squared, which is
4.
4. Make it smaller, even smaller by 3 times smaller. The Earth will be 3 times smaller than the radius, yeah? So the force will be bigger by how much is 3 squared?
9.
9. Very good. So this is very interesting. This is you can. Good. I think this is enough for today. Thank you very much.
Thank you very much.
And thank you for joining us. And hope you have fun. Please contact for any questions or comments or curiosities. And blessings to everyone.